Okay, this is still pre-calc section 5.2, the rest of our example here. On this problem right here, we're still proving, which means we want the left and the right side to equal each other. Both sides arguably are the same level of difficulty in my opinion. I went ahead and started with the left-hand side though because there is a binomial in the denominator, but technically these would both be the same thing. Now the common misconception on this particular problem, and I don't know why it's just this one, but people try to cross multiply all the time on these. We aren't doing a solve problem, we are doing a prove problem, so make sure that you're not trying to solve these guys. Okay, so to get the left-hand side to look like the right-hand side, this is a trick we use quite a bit. We want to get 1 minus sine beta somehow to turn it into cosine beta. And so this is kind of a couple-step process, but it's pretty easy once you see it the first time. So what I'm going to do on the left-hand side is I'm going to multiply by the conjugate. So I'm going to multiply by 1 plus sine beta for the numerator and the denominator. Okay, for the numerator, we're actually not going to distribute through this time, but the denominator, I am. So I'm going to FOIL on the denominator, and because they're conjugates, I only have to do the first and the last term. So when you do that, you should end up with 1 minus sine squared beta. And again, the numerator, I am choosing not to distribute through. Okay, pause, take a look at the right-hand side, see if you can see it. It's kind of there, kind of getting a little closer. Okay, next thing that we can do is go back to your Pythagorean identities. This should look familiar to us. We should know this one. 1 minus sine squared beta is the same thing as cosine squared beta. Okay, pause. Take a look at the right-hand side of your problem. We need 1 plus sine beta, which I have in my numerator, and I need just a cosine beta in my denominator. Well, if you look at your problem, you have a cosine beta in the numerator, and you have a cosine squared beta in the denominator, so those guys can cancel out. So I believe we get the right-hand side of the problem. All right, moving on to the next problem. In my opinion, the left-hand side is harder. We're still proving here. A couple different ways that you can attack this one. Secant squared theta minus 1. That looks familiar to me. Get your trig identities out and figure that out. You should be getting that as tan squared theta. Okay, pausing, taking a breath, looking at the right-hand side. It's not quite there. I'm going to have kind of an idea, but it's not quite there. So what I'm going to do is I'm going to change everything into sines and cosines, see if that helps me at all. So tangent squared theta, I know is going to be sine over cosine, so sine squared theta over cosine squared theta. And then the secant squared theta, I don't need to actually use the reciprocal rule twice on this problem. I can just use it once. This is already in the denominator, so I can kick it up using the reciprocal rule. And when I do that, it looks like this. So sine squared theta over cosine squared theta, that's where the tan squared theta came from. And then I used the reciprocal rule for secant squared theta, that turned into cosine squared theta. I just wrote it over 1 for visual awareness, nothing else. I'm multiplying two fractions together. I see a cosine squared theta and a cosine squared theta. They cancel out. Pause, take a breath, and we are there. You got it.